Hello and welcome to InSilicozy channel. In this video I'm going to show you how to install Gaussian on a Linux machine. First of all, I'm not going to show you how to install Gaussian on a Windows machine because I think the installation process there is very easy and you just need to enter the program key and then just press a few next button. So I don't think anyone need a tutorial for installation on a Windows machine. But here in Linux, the installation process is a bit complicated, especially if you're not familiar with the Linux shell. So I divide the installation process into 5 easier steps, and I'll give you a full description on what I'm doing in each step so that everybody, even newbie Linux users, hopefully can install Gaussian using this instruction. Okay, the installation steps are extracting binary files, set the permission of files, prepare the shell, make a scratch folder, and finally running a test job. We also have an extra step for multi-user machines. If you have more than one user on your Linux machine, you must do an extra step to make the Gaussian executable on all of your users or on all of the users which you want them to be able to use Gaussian. Another point which I must say before we get started is that in this video I'm gonna install Gaussian on Ubuntu and CentOS Linux distributions. But if you watch this video meticulously, you can use the instruction for install Gaussian on any Linux distribution and even any Unix machine. Okay, we'll start off with Ubuntu. This is Ubuntu 20.04. Okay, first of all, you need a Gaussian binary file, a file like this. Actually, this is a compressed file which contains binary files, and binary means executable, a file that you can execute on your machine. And the point is that you must find a suitable binary file for your machine, and especially for your processor, for your CPU. And if you check this page for Gaussian revision C.01, we have 3 different binary file, a legendary pre-SSE 4.2 version, and SSE enabled version, and one AVX enabled version. These features, SSE 4.2 and AVX, actually are different CPU instruction. So first of all, you must check your CPU, your machine, and find which instruction your machine has. And this 3 instruction is for revision C.01 and also for revision C.02. We have another binary file which is AVX2 enabled. So first of all, I check my CPU by opening a new terminal. Okay. For finding your CPU features, you must use this command, cat pros CPU info. By this command, you can find different features of your CPU in this line, which starts with flags, and you can see that my CPU has SSE 4.1, SSE 4.2, and also it has AVX2. So I can use the AVX2 version of Gaussian and install this version, which is the latest version of Gaussian on my machine. And actually I still can use all the binary files like this one, SSE 4.2, or this one, but because my machine, my CPU has a AVX2 instruction, if I install this version, I get a better result. I mean, this is a more efficient and fastest binary file for my computer. But if you have an old CPU which doesn't have AVX2 instruction, you can't use this binary file. And if you install this version, it gives you an error when you run the program. Okay, I start with a suitable binary file, which is it. Unfortunately, I can't provide you a link to download the binary file because Gaussian is a commercial software and you must buy a license for it. Although some students told me they found free binary files of Gaussian on the internet, but if you want to use them, it's on you, and I don't recommend you to do so. Besides the binary file, you need a setup file and a test input file, which you can download them from the description box below. Okay, I've put all the three files in a folder named Gaussian binary in my desktop. Obviously, you can put your files anywhere in your computer, but if you're a newbie Linux user, I recommend you to create a folder exactly with this name in your desktop and put your files in that folder, because it makes my instruction easier for you. Okay, let's begin with opening a new terminal window. Now I want to extract the contents of a Gaussian binary file in this folder, and I do this by provoking this command tar xvjf tilde slash desktop Gaussian binary. Okay, you should know that Linux is a case-sensitive operating system, which means it differentiates between capital and non-capital letters. So you must type this command exactly the same with XV capital JF, and then in the file path you need type desktop with capital D, and if you named your folder exactly as my folder, here you must type capital G and then here capital B. And I said this because I know it causes a lot of confusion for novice Linux users. Okay, tar is a command for extracting compressed and archive files, and you need to specify the path and the name of the compressed file, which is G16 C01 AVX dot tbj. Okay, here a problem that may confuse some users is that different Gaussian binary files, actually different archive of Gaussian binary files, may be compressed with different formats, and it causes problem because you need different options to extract different archive files. So if capital J option doesn't work for your archive file, you should also try J, Z and capital Z options for your archive file. Okay, here I have a XZ archive file and the capital J option works for me. But if I provoke this command in this way, I get an error which simply says I don't have permission or my user don't have permission to write in this folder, to write in the opt folder. So I have to extract the file with the permission of the super user, and I can do so by putting sudo in the beginning of the command. And then it asks me my password, and then it begins to extract the files. Now the extraction is complete and I can check the existence of the Gaussian folder by this command ls, which shows me that the Gaussian folder is here, or I can use ls lrt, which shows me more detail of this folder. So until now the Gaussian is in its place in opt folder, but the problem is that my user doesn't have the permission to execute the program. So now let's move on to the step 2, which is setting permissions of the files. Okay, first thing first, we need to create a new group for users who we want to use Gaussian. Sudo group G16. You can name this group any name you want, but I prefer G16, and then press enter. Enter your password, and okay, it's done. Now you must add your user to this new group by this command usermod ag G16 Dirac. Here G16 is the name of the group and Dirac is the name of my user. If you don't know your username, you can find it by this command who am I. Okay, and it shows you the name of your user, and you must see G16 in the output, but here I don't have G16, which means still my user Dirac is not a member of G16 group. To fix this, first I restart the terminal and open a new window, then groups, and still I can't see any G16. And if it doesn't fix the problem, just restart the system. Okay, now I've restarted the computer, and now we can see G16 in the output of the groups command. Now we can go to the opt folder by this command and set the permissions of the Gaussian just by two commands. Sudo ch own r root G16. The second command is sudo chmod r750 G16. Actually, the first command set the owner of G16 folder, and it states that this folder G16 belongs to root user and also belongs to G16 groups, belongs to users who are members of G16 group. And in the second command, 7 means the user owner of the G16 folder have all permissions, which means it can read, it can write, and it can execute all files in this folder. And 5 means the owner group, the member of owner group have the permission to read and execute. And the 0 means all other users have no permission. They can't read, they can't write, and they can't execute files in the G16 folder. And we can check the permissions by this command lsLRT, and the output line for G16 folder must be like this. You must have drwx r-x and 3 dash, and then here you must have root and G16 like this. Okay, so far so good. Let's move on to the next step, which is prepare the shell. And if you don't know what is a shell, this non-graphical interface is a shell. A shell is a program which takes commands from us, interprets commands, and sometimes gives us some outputs. So every time you open a terminal window, you work with the shell. And because default shell of Ubuntu and many other Linux distribution is bash, we need to set up bash shell. And by set up bash, I mean introduce the program Gaussian to the bash, to the shell, so that every time you open a shell terminal, the shell knows where is the program and where to write scratch files and some other variables. To set up bash, we need a setup file, but first of all let's go to the home directory by cd command. I provide you a setup file. You can download it from InSilico's website. I put the link in the description box below. So let's have a look to the file. You can see that this is a very simple file. The first line tells the bash where is the program, which is in the opt directory. The second line specifies the directory of the scratch files, which I create it later on. And the second line actually specifies the address of the main setup file of the Gaussian, and source tells the bash go to this address and read the setup file. And the last line actually is not necessary. This line is for Gauss view program, so if you don't need the Gauss view, you don't need this file and you can delete it. Okay, if you extract the binary file in the opt folder and create the scratch folder exactly where I'm going to create it, there's no need to edit this file and you can use it without any change. But if you want to change the program or scratch folder, you need to edit these two lines. And don't forget to save the file after that. Okay, we need to copy the file in a proper place by cp command desktop Gaussian binary, and this is a path of the file which is in the desktop and Gaussian binary, and the name of the file G16 setup, and I'm gonna copy it into the etc folder. Permission denied means you need to do it with the sudo permission. So I add and sudo to the command, and that is it. Now we must tell the bash, the shell of the Linux, where is the setup file. And we can do it by editing bash rc file, which is in the home directory. Tilde means home directory, and .bash rc is the name of the file. Okay. You just need to go to the end of the file and add an extra line source etc G16 setup. Okay, this is all you need to do, and then save the file. Okay, I've just edited the file with the VI text editor, but if you're not familiar with the VI, it may be a little bit confusing for you. And you can edit the file with the gedit text editor as well. Bash RC and then open the file and go to the end of the file and add this line and just save the file, and everything is the same. And if you don't have any graphical user interface, you can use Nano text editor as well. Bash RC, and after editing the file we need to close the terminal window and open it again. And if Bash doesn't give you any error, probably everything is okay, and then you just need to create a Scratch folder. And the name and path of the Scratch folder must be exactly the same as what is in the setup file, G16 setup file, which is it. So I just copy this part and then create the Scratch folder by this command, paste. Okay, after that you also can check the Scratch folder in the graphical window. This is home directory, and you must have a Scratch folder in the home and G16 folder in the Scratches, which must be empty for now. Okay, for the final task, let's run a test job. You can download a test input file from the InSilicozy website, water.gjf. I'll put the link in the description box. So let's run the test job. For running a Gaussian job, you just need to go to the folder which contains the input file. You can do it in graphical interface, such this, or you can type the address in the command line interface like this. Desktop Gaussian binary. Okay, and then use a ls command to see the input file in the folder and make sure that the input file is here, and then run the Gaussian by G16 command, and you must use a particular syntax for it, which is G16 angle bracket the name of the input file, which is water.gjf, and angle bracket the name of the output file, and you can use any name for output, but I use water.out, and then press enter. Okay, it takes a few seconds to complete, and after that, if it doesn't give you any error, probably everything is okay. So let's check the content of the output file. You can do it by cat command water.out. Okay, that is it. If the last line is the normal termination of the Gaussian 16, everything is okay. And well done you just successfully installed Gaussian on your computer. Okay, let's move on to the CentOS Linux and install Gaussian on a CentOS machine. Start. Alright, actually installation process in CentOS is almost exactly the same as what we did in Ubuntu, but there is only a subtle difference here, and that is in some older version of CentOS like CentOS 6 or CentOS 7. Your user account doesn't have sudo permission by default, and it is no big deal because you can enable sudo for your account. I'm not going to teach you how here, but you can find some high quality instructions on the internet, and I'll put the link of one of them in the description box. Or you can simply use the root account in old versions of CentOS or any Linux distribution which doesn't have sudo by default. Okay, now I'm in CentOS 9 and sudo is enabled by default in CentOS 9, but if you want to install Gaussian on older version of CentOS like CentOS 7 without enabling sudo, you just need to switch to root user by su command and then type the root password, and then you can execute all the commands that need root privileges without using sudo. And don't forget to exit root user after executing the commands. Okay, like what we did in Ubuntu, let's extract the binary file in opt folder. And now we need root permission to write file in the opt folder. So I'll switch to the root user by su command and then just enter the root password. Okay, notice in shell prompt the $sign has changed into hash sign, and it means that we are now doing jobs as root user, and this is same as putting sudo before commands. Okay, now we can extract files using the tar command, tar xv capital JF, and then we must provide the path of the binary file. But first let's find where is the binary file. By ls command. Okay, I've put binary files in the downloads folder of my account, which is Hossein, but now we act as the root user, so I can't use tilde sign because now it means the home folder of the root user, not my user, which binary file is in its home. So I have to provide the full path of the binary files, which is /home Hossein downloads Gaussian binary, and the last part is the file name g16-c01. Okay, let's test it with the ls command, and it's okay. So we can use the tar command by substituting ls with tar xvjf. It's okay, and extracting all the files. The extraction is complete. Now we must set the permissions of the files. First thing first, you need a new group for all users which you want to be able to use Gaussian, and you can create a new group by group add. I'll name my group G16, and then you must add your user to this new group by user mode ag, the name of new group and your username. Okay, then you must check if your user is a member of this new group. You must open a new terminal window and then groups, and it shows me my user isn't a member of G16 group as yet, so I restart the machine to fix the problem. Okay, now that I've restarted the machine, let's check the groups again. Alright, we can see G16 here. Now I can set up the permissions of the G16 folder. First, I go to the opt folder, and then I can check the initial permissions of the folder by lsl command. This is the initial permissions of the folder, and now I can change the permissions by these two commands: sudo chown are root G16 and I type my password, and the second command is sudo chmod r750 G16. Okay, if I check the permissions again, I can see that it has the right permissions and owner, and here root means the owner of this folder G16 is the root user, and the owner group of the folder is G16 group, which I created before. And here RWX means the owner of the folder, which is root, have all permissions, read, write and execute, and the owner group, which is G16, has write and execute permission, and all other users don't have any permission at all. Now we can proceed to the next step, that is set up bash shell. And for doing that, we can use the same file I used to install Gaussian on Ubuntu Linux. You can download the file from the link in the description box, or you can create your own file by typing its content. Okay, first let's have a look at the content of the file. I put the file in the download folder, so download and Gaussian binary G16 setup. As you can see, this is a very simple text file. The last line is not mandatory for installing Gaussian and is related to the Gauss view. The first line specified the path of the Gaussian program, which is in the opt folder. The second line specified the path of the Scratch folder for Gaussian. And if you want to change the directory of the program or the directory of the Scratch files, you have to change these two first lines. But if you extract the Gaussian in the opt folder and create a Scratch folder exactly where I'm gonna to create the Scratch folder, there's no need to change anything in this file. Okay, let's copy the file in the proper place. You can copy the file with the cp command, cp downloads Gaussian binary G16 setup to etc. You can copy the file by this command, but please mind that this part of the command is the path of the setup file in my system, and if you put the file in a different location on your system, you must address the correct location on your system. And because you don't have permission to write in the etc folder by default, you have to add an sudo in the beginning of the command. Okay, I type my password, and so far so good. Now we must edit the bashrc file of my user to source the setup file. For doing that, you just need to add an extra line in the end of the file, which is source etc G16 setup, and then I save the file. After doing that, to apply the Gaussian setup, you have to restart the shell and open a new window. Okay, if you don't see any error, check the Gaussian by test file, and I have a test file in downloads Gaussian binary folder. Okay, this is a test file, water.gjf, and I can run the job by this command and enter. Okay, Okay, you can see that the job is running and everything is good. And in the end of the file, I have normal termination of Gaussian 16, which says that everything is okay. And please note that I write the command like this to test file, but if you want to save the output file, you must add an output file name at the end of the command like this. And it must create output file water.out at the end of the job. Okay, let's move on to the last part, installing Gaussian on a multi-user system. Actually, we can do this in any Linux distribution, but for now let's come back to the Ubuntu. Here we already installed Gaussian on a user, and if you use my instruction, installing Gaussian on other user is very simple, because we already have the Gaussian binary in the right place and we have set up the right permissions for them, and also we have a viable setup file in its place. So for any new user, we just have to do two tasks: set up the bash RC file of the user and adding that user to the G16 group. Okay, let's do it. This is the original user Dirac, which I installed Gaussian on it. We can check it again by G16 command. Now let's say we have another user like Neoton, which we didn't install Gaussian on that. First, let's switch to the Neoton by su command and then typing the password. And now we are in the Neoton user. Okay, now I act as Neoton user, and if I check the G16 command again, it says that there's no G16 command on the system. So first I need to edit the bash rc file, bash rc, and source etc G16 setup. Please note that we already put the G16 setup in the etc folder, so we just need to add this line at the end of the bash rc file, and then I save it. Okay, now we have to add the Neoton to the G16 group, because we granted the permissions of the Gaussian binary folder to the G16 group, and we can do this by this command sudo usermod a capital G G16 Neoton. Okay, it just says Neoton is not a sudoers, and we can't use a sudo with this user. So let's come back to the Dirac user and type this command again, usermod and then restart the system so that usermod command take effect. Okay, I've restarted the computer, and this time I logged in as Neoton to check if I can run Gaussian by this user. So I provoke G16 command, and it's okay, but the only thing that I missed to do is that I also must create a scratch folder. So let's do it by mk directory command p, and if you forget where is the address of a scratch folder, you can find it in G16 setup file vi etc G16 setup. It's the address of a Scratch folder, and you can copy it and then mcode directory with P option. And now we must have a Scratch folder in my home directory, and it contains a folder which names G16. Okay, and then if I type G16 command, okay, it's okay. The final note is you can download the setup and test files from the InSilicozy website. I'll put the link in the description box. And if you are a scientist and you are interested in computational methods in chemistry, biology, physics, material science, or drug design, please subscribe this YouTube channel, and I'll provide you more scientific computational videos.